Hey, welcome back to Red Alt Key. In Module 5, we're unraveling Docker image complexities and diving into the image registry. Efficiently managing images and understanding registries are essential Docker skills. Let's dive in. In a previous video, I spoke about the Docker registries, and in this case, it was the Docker image registry called the Docker Hub. Please note that this is not the only Docker image registry. There are others. However, for this exercise, we will focus on this one, which is the Docker Hub. What we'll do is create an image locally, Docker image, and then we will push it to this Docker image registry. Let's spin up the terminal. I'm going to create a folder called repository. And then I will go into it, and then I'm going to create a new file called Dockerfile. In there, I'll use a source image, Ubuntu latest. And then I'll define a working directory called app. And then I'll run a copy contents of the current folder or current directory into app, and then I'll run a command which is echo hello Docker Hub. And that's it. From Ubuntu latest working directory app, copy current contents to app, run the command echo hello Docker Hub. We'll save and close. I've already created a Docker image registry account here on the Docker Hub, and it's called Red Alt Key. So that's the account, Red Alt Key. And as you can see, there are no images here. So let's get started with the process of, first off, building the image and then pushing it to the Docker image registry. We'll run that with Docker build. The -t refers to a tag. It can either be -t or --tag. And we'll call this Red Alt Key. And it is simple echo image. And it's going to be version 1.0. And we do a space and a dot. If you remember the Dockerfile, there's a section where I ran a copy command, which was copy dot space / app. The dot means current directory. So in the context of this build command, the dot at the end says, it implies that we should run this build command based on instructions that exist in this same folder or directory. If you remember, the only file that exists in this folder or directory is the Dockerfile, and it has our build command or build instructions. I'll press enter. It has built our image called Red Alt Key simple echo image. Let's run Docker image ls. There it is at the very top, Red Alt Key simple echo image, and it has been tagged as version 1.0. And it has a size of 77.8 megabytes. You might be wondering, why is it that large? You only had 4 lines of text there. Remember the first line, it imports the Ubuntu latest image. So that size is mostly that image. This image is currently still stored on my local computer, but I have to copy it over to the Docker registry. So what I'll need to do here is tag it and prepare it for the push to the image registry. Let me clear the screen once more. And this time we're running a Docker tag command. And then we are referring to the image by the name that I just gave it, version 1.0, and we're tagging it using a name that it will be called by on the Docker registry, which is going to be the image name, but instead of v1.0, it's going to be latest. Press enter. Let's go back up and run docker image ls. Now it appears twice. The first one has a tag of v1.0. The second one has a tag of latest. Notice something interesting in the third column, the image ID. The image ID is the same. So what this means really is that we have tagged the same image with 2 tags. First tag is the v1.0, second one is latest. However, the one that we need to push to the Docker registry is latest. I've already given you the keywords push, which is going to be the next thing that we'll do. We're going to be pushing the image with the latest tag to the Docker registry with the Docker push command. So it's Docker push and then the name, red alt key / simple echo image. Which tag do we use? v1.0 or latest? We use latest. Like that, and press enter. Request denied. The request has been denied because I need to log into my Docker Hub account. Let me pause the recording for a moment while I authenticate into the Docker Hub. Hello, I'm back. So as you can see on my screen, that's the command that I ran to authenticate into the Docker Hub through the command line. And the command that I ran was docker login -u space and then my Docker Hub username, after which it prompted for my password. And then it says that my password will be stored unencrypted in home my user account .docker /config.json. Let's go ahead now and run that previous command, which is the docker push. Docker push, red alt key, simple echo image, latest. Pushing the image. You see that is also mounting it from the Ubuntu library. And it's done. Let's go into the Docker registry, refresh, red alt key, simple echo image is now in the Docker Hub. And it is the latest version. Click in it. There you are. Has been compressed down to 28.18 megabytes and is compatible with these 2 architectures. One thing that I forgot to do was run the image to test it before we uploaded it or before we pushed it to the Docker registry. We do that with the Docker run command. So we're going to run Docker run, right alt key, simple echo image, and we'll be running the version 1.0. There, it just prints the words hello Docker Hub. What we're going to do this time is make changes to our original Docker image by updating the Dockerfile, and then we'll push the updated image into the Docker registry as well. I'll clear the screen and I will nano Dockerfile, and what we'll do here is say version 1.1 and close and save, and then Docker build tag red alt key simple echo image v1.1 space dot enter Docker image ls v1.0 is there, latest is there, and v1.1 is there. So what we will do is clear. Let's run the container. Docker run, red alt key, simple echo image v1.1 hello Docker Hub version 1.1. What we'll do this time is push the version 1.1 image using that same tag. So we're going to use Docker push red alt key, simple echo image 1.1, that's what we use. Push. Something interesting here is that after I ran the push command, it has layer exists and layer exists. It is recognizing that I've already uploaded or pushed a version of the same image, however with differences. So for those items that are still the same, or those items in the previous image that have not been updated, Docker will not re-upload those same components, but instead it links the new image. Let me rephrase myself. It links the unchanged items or unchanged properties of the new image to the same items in the old image. This is a means of avoiding duplication, or it's a deduplication process. Let me go into the Docker Hub. and go to repositories. We still see one image. Click on it. It has 2 tags. I have the original one that I'd refer to as latest and a v1.1 which I just updated now. So that is the process of pushing a Docker image onto there. So let me just try out something else here while I'm still here, because the image that appears as latest is no longer the latest. The latest one is this one here. Let's see what happens. This is just me experimenting here. If I push this same image, not as v1.1 but as latest, let's see what it will do. It recognizes that this image or this version of image exists. So let's go back into the registry and see what it has done. I'll just refresh this same page. Okay, so v1, oh, let's see all. Okay, it has a v1.1 and it has the same one because it was within the last 2 minutes. So I have the same image twice, once as 1.1 and once as latest. I have lost the previous one, so I can push. How can I do this here? I think I can just push v1.0. I'm pushing a local image by that name. So by a local image by that name, I mean this. I still have the old image, which is the one tagged 1.0, and then the newest one is really these two. I refer to it as latest and as 1.1. Let's go back to the image registry and refresh. Yeah. 1.0. That is interesting. So what matters really is the order, I guess. So now that I've pushed 1.0, what I'm trying to do is have it such that the newest is at the top and it's also the latest, and then the older one is down there. So now that I've pushed 1.0, what I'll do is push 1.1 and then I will push latest. It's just me messing around here. I need it so that the oldest one is at the bottom there, and then the newest one comes up by its name, and it also comes up as latest. Whenever you refer to an image, whenever you refer to a Docker image by its name without the tag, let me show you what I mean here. Docker image ls. Whenever you refer to an image, by image name I mean the names on the left column here. If you refer to, for example, Ubuntu by its name rather than Ubuntu :20.04, you will get the latest tag. So if you refer to an image in your code or in your app as, say, Ubuntu like this, what Docker will do is look for Ubuntu latest, and in this case Ubuntu latest is probably Ubuntu, the LTS one. It will be Ubuntu 22.04. So whenever you push a new image of your, whenever you push a new version of your image to the Docker registry, you in a way push it twice. You push it once by its actual version name, and you push it by the latest tag. The latest tag is like a catch-all. If a programmer or if someone who is creating a Docker image somehow forgets to mention the tag, Docker will get the latest tag by default. Next up, I'm going to show you how to clean up Docker images by removing unused Docker images. We'll use the Docker image prune command. Docker image prune -a, enter. Warning, this will remove all images without at least one container associated to them. What does that mean? It means that if you don't have a container running, for example, if you run the command docker ps, you can see that there are no containers running. Let me see if there's a container that I can run. Okay, looks like that runs, so I'm going to run it in the background. What am I doing? Should be here. Okay, so if I run docker ps, the Flask app is running. So if we go back and run that image prune there, so it says, warning, this will remove all images without at least one container associated to them. In this case, a container is that Flask app that is now running. When you run an image, it runs as a container. So I have a Flask app image out of which I have started running a Flask app container. So when I hit yes, it should delete all the other images on this computer, 2.5 gigabytes worth. I'll clear that. And then if I run docker ps, the Flask app is still running. And then if I run docker image ls, the Flask app is still there. I did already run the version 1.0 and the version 1.1 of the simple echo image. And in the past, I've run the super, the MyEngineX, and just today I ran the Flask app image as a container, which is why they have not been deleted, because they have containers. The containers don't need to be running, they just need to exist. So what we've done today is create a Docker image, push the image into the Docker Hub, which is the Docker image registry. We then went back and made changes to the image in the Dockerfile. We then pushed that image back again onto the Docker image registry. I logged into the Docker image registry and showed you the versioning of these images as we push them into the hub. And then at the end, I showed you how to clean up unused Docker images. You've navigated Docker image intricacies and conquered Docker Hub. Subscribe for more tech insights and stay tuned for Module 6. See you on the next video. Bye.